The coordination number and oxidation state of chromium in K3Cr C2O43. So you can see now what kind of a complex you have. The complex is being written on the right hand side. It's coming later. That means it's an anionic complex. You can write 3 minus here. So Cr C2O4 3 minus. So X, you have the charge 2 minus on one oxalate. We have 3 such oxalate. The coordination number is 6. We can clearly see it's a bidentate that we have. So X is going to be equal to, X minus 6 is equal to minus 3. So X is going to be equal to minus 3 plus 6. That means X is equal to plus 3. Your charge on chromium is plus 3. But the coordination number is 6. So 6 and 3, C becomes the answer to this question. Please see. Easy peasy, isn't it? Okay, let's check this question. It says a chelating ligand must possess 2 or more lone pairs at such a distance that it may form suitable strain-free ring at the metal ion. NH2NH2 is a chelating ligand. Well, this is absolutely true. It is a chelating ligand because it can donate 2 lone pairs like this. But do you understand the kind of the ring that you will get is a 3-membered ring? Is hydrazine a chelating ligand? What do you think? It's a great takeaway question for you. You just read the assertion, right? You're saying assertion is true. This is saying that it should form strain-free rings. Is a 3-membered ring a strain-free ring? Ask yourself this. The answer might... This is AIMS 2010. Don't take it as a light question. This is something that even JEE advanced students get it wrong at times. So please keep in mind, always if there is a ligand having 2 donating sites, doesn't make it a chelating ligand. There are exceptions. It should be a strain-free system, a strain-free ring that should be formed. That's first and foremost condition that should be fulfilled. Okay, so we'll go with rather now. Assertion is correct, but the reason is incorrect. C is absolutely correct. Okay, good question. It is a good question, right? Interesting? Chalo, let's move on. The sum of coordination number and oxidation number of metal M in the complex, this one is now oxidation number of metal. Okay, so I think no doubt about it that we have just one oxalate. So C2O4 is a bidentate. And since it's a bidentate, that means coordination number is 2 for just oxalate and ethylene diamine. And that too is a bidentate. There are diamines. So there are 2 of them. So one diamine is going to have 2 donating sites and we have 2 such. So 2 into 2, that means 4. So coordination number is 2 plus 4, that is 6. Now comes the charge. How do we find the charge? Are we clear that because it is Cl minus here, this will be a plus. So we have a positive complex here. This is a positive complex with the positive charge. En doesn't have a charge. Oxalate has 2 minus charge. A plus is hovering over this. So X minus, you have just one of these. So minus 2 is equal to plus 1. So X is equal to plus 3. You have got the charge. You have the coordination number. 6 plus 3 will give you the answer as 9. So D becomes the answer to this question. Good one. Questions. Very quick. So we have CrF2En2Cl. First, figure out what is the oxidation state. Fluorine, you already know, has a minus 1 charge. En, you already know, ethylene diamine has 0 charge. X minus 2, and we have just 1 chlorine here. So plus 1 outside. So X is equal to plus 3. Now this may rule out some of your options. Not here. All of them were 3 here. Okay. Next, now you can see that you have chromium, which is there in a positive complex. So you have to write it as chromium only. Other than chromium written, rule that out. Nothing changes here also. You will never write chloro first. That's outside the bracket. The other one has double M. So this is also incorrect. Okay. So you can see I am going with difluorido bis, ethylene diamine, chromium chloride. Now the question that I myself asked when the question was asked in NEET examination was, why is F written before E? Because A, B, C, D, E and then F comes, right? But anyhow, because the options are such, we will choose the best possible option from here. Oh yeah, fluoro is also there. Amine was also there. So B is the perfect answer that we have. There you go. But fluoro was once upon a time accepted, no more. So if you have to choose the most appropriate one, go with fluorido always. Never go with fluoro. Similarly, cyano, no, cyanido. Next one. Okay, you can answer me in the chat only. IUPAC name of the mercury complex is there. Now, after a long time, we have an anionic complex coming up. Let's see. In this case, the metal ion as it is. So you know that the metal ion as it is, this is not how you write. D cannot be your answer. A and C. C is also coming as the answer. Adil is saying C, but Sangeet, Shobhan, Parinita, Manani, Ashifa, Usha are saying A. Adil, would you like to change your answer or you stay with C? Great. So here we have mercury. Great. Now you can see we have to look for the charge. It's written 2, so I'm not even finding it. Now next is tetrathiocyanato. Written here tetrasulfato. So you understand this is CNS, not central nervous system. You being biology students might think of CNS as central nervous system, but yes, it's the carbon, nitrogen, sulfur, not NCS. No, we do not have a simple sulfato here. We have a thiocyanato. NCS is for thiocyanato, so it's written as CNS. Works for us, right? So tetrathiocyanato, not tetrasulfato or tetrasulfo. Sulfo, though, any which ways is incorrect, right? Now we have cobaltate 2. So A is the perfect answer for this question. Nobody liked B, so we are not even discussing B. All right, next. Now you have cationic complex only. A. Everybody is liking A. So do you understand platinum as it is? Then what is the charge? 444 written everywhere. Why to find? So amine, A-double-M. How many? 3. So triamine. So amine is there, bromido is there, and the next one is nitro is there. In fact, again, here the better one should have been NO2 is what do you call NO2? Nitrite, right? So it should have been mentioned properly, but nitro here works because the examiner only is giving us, so it's okay. Now you can see all the options had nitro, so it is not a point of worry for us. Then chloro is chlorido. So this is an old question. This you would find in most of the books where you would see that the books have made use of chloro and nitro. But now if you see any modern question, maybe after 2018, you would not see any of the O's written as it is, like in nitro or in the case of the chloro. It will be changed. But if you see them in the previous year questions, accept them because for the longest time we had been using it, right? Okay. So in that case, decide for the best one here. Triamine, bromido, chlorido, nitrito, platinum 4 chloride. This would have been the perfect answer. But out of these, we'll go with A. Question coming your way. Try this out. Ulta question is now the name has been given. Figure out the structure, the formula. Okay, we can see that we have chlorido. That means there is chlorine. Aqua. That means there are water molecules, 2 of them. Triamine, that means there are 3 ammonias. So 3, 4, 5, 6, coordination number 6, cobalt 3. Now because it is cobalt, we know it's a cationic ligand. So we will write the cobalt first in the complex. Then chloro, ammonia and H2O. You can see Cl, NH3, 3, H2O, 2. This is how we have written. And then Cl2. Please check Cl2. Why are we writing 2 here? Is it clear? Now you have to understand that when cobalt 3 is given, that means this has a +3 charge. Chloride has a -1 charge. Ammonia has 0 charge. Water has 0 charge. So this is a charge on the complex, which is equal to +2. So you won't write +2, but rather you can just balance it by writing Cl here. And that can be a little complicated. You have to keep that in mind. Okay? You have to keep it in mind that you here rather know the oxidation state. From the oxidation state of metal, find out the oxidation state of complex and balance your complexes. All right. I hope it is clear. You got a good practice. Now, IUPAC nomenclature beauty is I can increase the level. I can complicate the questions by asking you this name. And we'll ask you what is the geometry involved here, tetrahedral, octahedral, or which of the following correctly represents the structure of this complex. So there, it's not just the complex which is being tested, but your denticity also, because there will be cobalt to it. There are going to be how many chlorides? 1 chloride. There are going to be how many water molecules? There are going to be, you can see diaqua, that means 2 water molecules. Then there are how many amines? 3 amines. Then what I can ask? I can also ask if this has isomerism. So I can increase your level if you observe. Can it have the isomerism? That can also be a question. We will talk about that tomorrow. So you can see that there can be Fackenmer here. So all of that can be contributed, can be asked here. Okay, so that is why I've taken up names, though even though you guys are doing amazing here, the level keeps on increasing with the name and crazy questions are possible. All right, so let's now move on. Here is a question for you. Let's see whether you can attempt it or not. So you can clearly see that the correct order of the stoichiometry of AgCl formed when AgNO3 in excess is treated with the complexes. So you can think of the 6 ammonias, they would not be counter ions. They would certainly be inside the complex. So that means it would be like this. And the 3Cl3, 3 chlorides outside. Similarly, now that we have 5 ammonias, so one has to be satisfied with the chlorine, though we do not know how it is sitting the way it is. What will be the coordination polyhedron? We do not know these questions, and that's why we need the next theory. VBT will help us in understanding what will be the geometry of the complex with the help of the moment, the magnetic moment it will show. The paramagnetic and diamagnetic nature helped us in understanding the polyhedron, how the molecule looked like, how the coordination compound looked like. Okay, but this has nothing to do. This is just our already perceived knowledge about coordination chemistry, which is helping us here. So when we have 4 of them, then 4 are going to be inside, 2 satisfied by the 2 chlorines inside, 1 chlorine outside. So here, 3, here we have how many left? 2 chlorines left here. We'll write it here. So this is the second one, and here 1. So 3, 2, 1. That means answer is 3, 2, 1. What are you saying? B? B becomes the answer. Absolutely right. Now, very interesting question coming your way. Similar question, very similar lines, but it's very interesting. This is AIMS 2016 question. So do you understand this question is again based on the Werner theory only, based on the ionizable species. It's a simple question if you think about it, but some data might be misleading here. That's it. Okay. So do you understand here actually the volume plays no role. Okay. So if you're taking 200 ml of the first or the second one, doesn't matter. Here you have 2.02 moles of this. That means these are the ionizable species, correct? Do you understand? Cl2. So 2 ionizable species out here. That means please make sure you do not find the charge of the cation. That has nothing to do here. Okay. So that means the 0.04 moles of AgCl complex will be formed. The number of moles of precipitate. So this will be our Y. Similarly, what will be Z? Just 1 sulfate here. Ionizable species is just 1. So 0.02. So 0.04 and 0.02 becomes the answer to this question. That means D is the answer.